So with our Directv Bill problem, we said that $59.95 is what you pay each month. $4.95 is what you pay for each on-demand film, and we're looking at our monthly bill related to, or as a function of, the number of on-demand movies we view. So we do know this is a function because depending on how many on-demand movies we view, we should be paying one fixed price. So if we only watch one on-demand movie, we'll be 10 cents shy of $65, and I think we're right at $64.90. Well, what if you watch two on-demand movies? Of course, you're still paying your base $59.95. Notice how I'm always going back to the base price, and I'm going to add $4.95 to that, but I'm going to have to do it twice, right? I need two copies of the $4.95, as I'll state it. Two copies of that because I'm paying that twice. So 2 times $4.95 would put us, let's see, $69.85, I think. Double check me on that. $69.85 is what we pay for 2 movies. Well, hopefully you're beginning to see the pattern. That to calculate my bill, to get the value here, here, and here, I am taking the $59.95 base price, I'm adding to that the number of on-demand movies I watch, and multiplying that by $4.95. So really, up here I actually multiplied 1 times $4.95 because I only watched one on-demand movie. So I can actually rearrange this a little bit because what do we know from our math experience? Well, we know that, let me find a clean page here, that I can actually add, if I add 2 things together, 5 plus 4 and 4 plus 5, those are exactly the same thing, right? So I can actually move, if I want, the $59.95 to the end, and I can move the m times $4.95 to the front. That's the same thing as 5 plus 4 equals 4 plus 5. And I also know that 5 times 4 is the same thing as 4 times 5, so if it makes it a little bit prettier, more convenient, I can do 495m plus 59.95, again, because 4 times 5 is the same thing as 5 times 4. This multiplication is commutative, so I can write my answer in this way. And since the bill is a function of the number of on-demand movies I watch, I can also state it this way and answer questions about this, like, well, if I only want my bill to be $70, how many movies can I watch? And that's something we'll address a little bit later on, since we would have to address that with the equation, but we could answer a lot of questions with this. One final thing that we'll talk about here is practical domain and practical range. Practical domain is a set of input values, set is important here, that make sense in the problem. Typically these values are stated as an interval, minimum and maximum. The practical range is a set of output values that make sense in the problem, again, stated as a minimum and maximum. So let's go back for a second and look at the part-time job problem. Our input is hours, so that is what we would talk about when we'd be determining domain. So domain would be, well, from what to what hours do you typically work? Well, it tells us here that you typically work between 0 and 30 hours per week. So we would state our domain, our practical domain, in the following way. We'd say 0 hours to 30 hours. And what would our practical range be? Well, our practical range would be a set of output values that make sense in the problem. So if I work 0 to 30 hours, what will my pay range between? Well, if I work 0 hours, that's when I earn nothing. So I could potentially earn $0 up to, well, what would be the maximum pay I'd get? I know that I get $8.25 an hour, so my pay for 30 hours would be $8.25 times 30, and that would come out to $16.50, $24.75. No, excuse me, I'm wrong. $247.50, I believe. Check me on that, but I believe that's right. $8.25 times 30. So that would be my pay for my potential pay, practical domain, and practical range. I could do the same thing for the other problem.